Today we're going to be talking about factoring by GCF. Before I actually get into factoring, let's talk about something that let's make a connection to the things that we've already been working on and talk about something that we've already done. For example, let's say that I gave you the problem 2x times 3x squared minus 6x plus 1, and I asked you to simplify that. Most of you would tell me what you need to do is distribute. You'd be exactly correct. I'm going to distribute this monomial 2x through the parentheses to everything inside the parentheses. So my first step is to multiply. I'm going to be multiplying 2x times 3x squared. So to review our rules of multiplying with like bases, multiplying monomials with like bases, we're going to multiply our coefficients. 2 times 3 is 6. We have an invisible exponent of 1 right here. So when I do x to the first times x squared, we add our exponents. So we're going to have 6x to the third. Continue multiplying through the parentheses. 2x times negative 6x is going to be negative 12x squared. And 2x times 1 is 2x. So for factoring, so here I have a monomial times a polynomial, and the product is right here, 6x cubed minus 12x squared plus 2x. With factoring, we're actually going to be going the opposite direction. Instead of being given two monomials or polynomials and being asked to multiply them together in order to get a product, I'm going to give you the product and ask you to tell me what polynomials multiply together in order to give me that product. So let's begin by talking about factoring by greatest common factor. Let's start with numbers, which is something you've probably done this before. Let's say I asked you to find the greatest common factor of 32 and 48. In order to do that, you would have to determine what all the factors are between 32 and 48. So if I started with 32, my factors of 32 would be 1 and 32, 2 and 16, 4 and 8, and that would be it. There's all my factors of 32. For 48, I would have 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. There's all my factors of 48. The greatest common factor is the biggest factor that they both have. So they both have a greatest common factor of 16. They have other factors in common, 1, 2, 4, and 8. 1, 2, 4, and 8. But the greatest common factor is 16. So that's how we do that for numbers, but we also have to be able to do this for variables because we're going to be dealing with variables as well. So if I asked you to find the greatest common factor between x to the fifth and x to the third, you would follow the same process. My factors for x to the fifth are 1 and x to the fifth, x and x to the fourth, x squared and x to the third. The reason why is because if you multiply any of these pairs together, you get x to the fifth. And I would do the same thing for x to the third. One and x to the third, x and x squared, and that would be it. And now I want to find the greatest common factor between them. So if I look at this, they have a 1 in common, they have an x in common, they have an x squared in common, but the largest common factor, the greatest common factor, is x to the third. So the greatest common factor between x to the fifth and x to the third is actually x to the third. Now let's apply that. Let's do one more example. Let's go straight to a set of polynomials. Let's say that I gave you 5x to the third and 70x squared y. And I want you to find the greatest common factor between these two monomials. So we would start with the numbers. We want to find the greatest common factor between 5 and 70. You can list out all the factors if you need to, but I'm going to shortcut, and I'm going to tell you that the greatest common factor between 5 and 70 is 5. So far, my greatest common factor is 5. Now let's look at the variables. I have x to the third, and I have x squared. So both monomials contain x, and now I just have to decide what's the greatest common factor. Well, again, you could list out the factors if you needed to, but what I'll tell you is the greatest common factor between x squared and x to the third would be x squared. X squared goes into x squared also goes into x to the third. And then I want you to notice that this second monomial has a y variable, but the first one does not. If they both don't contain the variable, then certainly they can't have that variable in common. So there's no y in my greatest common factor. In fact, this would be my greatest common factor for these two monomials, 5x squared. So how does this apply to factoring? Well, you're going to follow the following 3 steps. I'm going to give you a polynomial, and your job is going to be step 1, identify the greatest common factor. Step 2, divide out the greatest common factor. And then step 3 is going to be to rewrite your factors. So those are going to be our 3 steps. So let's take an example problem. Let's factor 21x minus 14. So first I have to identify my greatest common factor. What's the greatest common factor between 21x and 14? It's 7. So I've identified my greatest common factor as 7. That's step 1. Step 2 is to divide out that greatest common factor. So I'm going to divide this by 7, and I'm going to divide this by 7. Now we're going to apply our rules of division. We're going to simplify our coefficients and subtract our exponents. 21x divided by 7 is 3x, and negative 14 divided by 7 is negative 2. And so I have 3x minus 2. Now that's not my final answer, because I need to give an answer of 2 factors that multiply together to give me 21x minus 14. So what would I multiply 3x minus 2 by in order to get 21x minus 14? I would multiply it by the greatest common factor of 7. So your greatest common factor goes outside the parentheses. And inside the parentheses is what's left over after you divide. Now I just want to point out, as I did at the beginning of the video, in order to check this, all you would do is actually multiply this out. If I multiply by distributing, 7 times 3x gives me 21x, 7 times negative 2 gives me minus 14. So that's how you can actually check this, is by multiplying these 2 things together and making sure that you get your original problem. Let's do another example. Let's try 9x squared plus 6x to the 4th. Step number 1, identify my greatest common factor. Greatest common factor between 9x squared and 6x to the 4th. Starting with the numbers, coefficients. The greatest common factor between 9 and 6